Hello students, welcome to Unit 3 Notes, Section 9.1. I've already taught this. I taught this lesson live, so I'm just going to go over the notes for those of you who weren't here. I'm going to leave them written as they are and just quickly read through it. Should only be about a 15-minute video. So the first thing was our warm-up that asked us to complete the congruent statements, given that triangle ABC is congruent to triangle EFG. What's awesome is I don't even need to look at the triangles. I can kind of ignore them because this statement here tells me the order in which things are congruent. So angle A is congruent to angle E, angle B is congruent to angle F, and angle C is congruent to angle G. They go in order. So for E, I put angle A, for C, I put angle G, and for angle B, I put angle F. So you do is, like for instance, angle B is right here, you pull it right from the middle there. If I said angle CAB, you would then say that's congruent to angle GEF. So you just, even with three letters, you go in the same order. So here, segment BC, which I have here, it was congruent to segment FG, and it goes in, again, the same order. What I did do is I put some tick marks here. I put A, which was congruent to E, B, which was congruent to F, and C, which was congruent to G. Notice I did not put right angles because I can't assume that. Not sure. It could be 89 degrees, could be 91, could be 90. I don't know. But I just put the tick marks to show that they are congruent. Then you have congruent side ones in no particular order, but they do match. All right. And so completing this statement was pretty easy after I went through there. TK is going from the middle to the first one, so that matches GL from the middle to the first. And TQK, so TQK went like this, TQK, so that would be angle GRL. So I just follow that pattern. All right, so what we started was this unit. This unit is with transformations. So transformations, we have translations, which are congruent, reflections, which are congruent, and rotations, which are congruent. So if we were to translate, reflect, or rotate, so if we were to slide, flip, or spin any shape, it would stay congruent and would look the same. Here, and so today we're on translations. The only other thing we're going to learn throughout this unit is dilations, which are not isometries, which are not congruent. So we consider isometries congruent and dilations, which is not an isometry, not congruent. So isometry is congruent. The image that happens before is called the pre-image, and the image that happens after is just called the image. So you have a pre-image. For instance, if ABC was flipped, ABC would be the pre-image, and then this would be our image. ABC would be EFG. All right, so, composition is when you do more than one. So if you slide it and then slide it again. So identifying isometries. A transformation of a geometric figure is a change in its position, shape, or size. A change in its position, shape, or size. These three do change its position, but not its shape or size. Dilations affect size, but not necessarily shape. Okay, so here, think about a jigsaw puzzle. When you assemble a jigsaw puzzle, you often move the pieces around by flipping them, sliding them, or turning them. Each move is a type of transformation. The photos below illustrate this. So here you have a reflection. Again, the shape and size are the same, but its position is a little bit different. It's been flipped. A translation is when you slide a puzzle piece somewhere, and a rotation is when you spin it. So it's the same piece, but it's being spun, flipped, or slid. So make sure you write in those notes right there. So the original figure is a pre-image. the resulting figure is an image. So here's your pre-image and your image, assuming that it went from here to here. Let's say this one went from here to here. That's my pre-image. This is my image. Okay. So this is a dilation. What I did was I made a triangle and I copied and pasted and I made it larger. And so what you know about that is that that dilation is not an isometry because it's not congruent. Okay. So now when we're talking about isometries, we have to talk about its mapping. So in this case, JLQ flipped. It looks like it reflected across a line. JKQ, and now it's J prime, K prime, Q prime. So what you notice is J is congruent to J prime, K is congruent to K prime, Q is congruent to Q prime. So JKQ mapped onto, and see that arrow? That means mapped onto. So mapped onto J prime, K prime, Q prime. So we can read it, but what we do is we use the mathematical symbol with the arrow to represent mapping. All right, so a transformation maps a figure onto its image, and it may be described with an arrow notation. Prime, that little tick mark notation, is sometimes used to identify image points. If the diagram at the right K prime, the image of, it's the image of K. So K mapped onto K prime. So you can say the angles, the points, the sides, the triangle are all mapped. Notice that you list corresponding points to the pre-image and image in the same order as you do for corresponding points of congruent or similar figures. All right. So do the following transformations appear to be isometries? Well, this one is definitely not, because they're not the same size. They are the same shape. This is a dilation, so we put no, this is not an isometry because of dilation. Here, we said, yes, this is an isometry. It could have either been a reflection, it could have flipped, or it could have spun. So we said that this is an isometry, but it is either a rotation or a reflection. This last one is an isometry. It looks like it reflected. The order changed, so it looks like it goes one, let's say we were going clockwise, we went down this longer side and the shorter side, well, the middle and the short side. Now I got to go down the middle and the short side this way. So because it looks different, even though it's the same size and shape, well, the shape has changed because of its flip. Okay, but in terms of its angle measures, they're all the same. So it's an isometry, it's a reflection. So list all the pairs of corresponding sides for this one. Here we have EFGH mapped onto E prime, F prime, G prime, H prime. So I wrote that right here. I actually should have answered that question first, even though it's asking for it to be written in D. But there's E prime, F prime, G prime, H prime. And so what I wrote here, and you can pause the video because I'm going to go through it quickly, is that EF maps onto side E prime, F prime, and side FG maps onto side F prime, G prime. Line segment EH, E prime, H prime, GH, G prime, H prime. All the angles match as well. So angle E maps onto angle E prime. So these are congruent, these are congruent, these are congruent, and these are congruent. I could have also listed it in this form. I could have written angle E maps onto angle F prime, but I just wanted you to see that they are all congruent, but they all could be written in this mapping form as well. So I wrote them in the mapping form for this one because it says what are the images, so this has to be answered this way. So the image of angle F is angle F prime, and the angle H is angle H prime. Okay. Now, not all triangles need to be, I don't know, SUP and S prime, U prime, P prime. It could be SUP maps onto DIN or NID. So it looks like NID maps onto SUP. So this looks like it rotated because it's going in the same order. NID, SUP. Yeah, so it's not it's just a rotation. So in this case, you have we could have written in the mapping form, which I did here, all my angles. You could also write it in this form, talking about the corresponding sides that are congruent. Okay, and then I wrote the mapping for I and for point D. So angle I comes from the middle, so it's angle U, and angle D is congruent to angle P, so angle D is congruent to angle P there. Oh no, that says point D. I need to fix this. Point D maps onto point D maps onto point P. I made an error there. Well, good thing I went over it again to fix it. And then this is triangle DIN maps onto triangle PUS. And that's it for that. So now here is, I think, one of our last slides. We're getting close. Translations. So a translation or a slide is an isometry that maps all the points. So what we do is we write it in this transformation mapping rule. So in this case, what I'm doing is I'm taking A, B, C, D. I'm taking this right here. And I'm mapping it. I'm sliding it over this way, 1, 2, 3, 4, and then down 1, 2. So I went over 4, so I added 4 to all of my x values, and then I went down 2, so I took 2 away from all my y values. And that is how we write the mapping. So we write it as x comma y maps onto x plus 4, y minus 2. Whatever I have for x, I'm going to add 4 to it, and whatever I have for y, I'm going to take 2 away. And that's how I write it in that mapping with a little arrow to tell my reader that's what's happening. Don't forget, x's are positive this way, y's are positive this way, y's are negative this way, x's are negative this way. So that's why I wrote the plot positive and negative. And then the composition here is the composition of transformations is a combination of 2 or more transformations. In a composition, each transformation is performed on the image of the preceding transformation. So what happens is you have one transformation happening and then followed by another transformation happening. So you have xy mapping onto x plus 3, y plus 3, and if you also have another thing happening to it where you add 4 and 4, then the total is 7 and 7. If you take something and you translate it plus 2 minus 6, and then you translate it again minus 4 plus 5, what you do is you finally what you did was you translated it minus 2 minus 1, because you moved it down 6 and up 5. It ended up being down 1 when it was finally done. Then you moved it to the right 2 and then to the left 4, when it ended up moving 2 to the left. So you just add those together when you're doing a composition. All right, example 3, finding a translation image. So like above, we are going to write the image of this. So what we want to do is we want to take the triangle XYZ and we want to move it to the left 2, that means to the left, and down 5, right? Because negative 2 would mean that this triangle would move 2 units this way and then down 5. And so what I did was I showed the mapping of this. You don't have to draw these every time. You don't have to draw them at all. You just need to draw the pre-image and the image afterwards. Now, what I did was to find out where it's going to go, I wrote the coordinates of x, y, and z. So x is at 2, 1, y is at 3, 3, and z is at negative 1, 3. And after we translate it 2 to the left and 5 down, what I do is I take 2 from all of these numbers in the x coordinates, and then I take 5 away from all of these in the y. And you can pause it and write this down, but this is how I would move this triangle here down and to the left. Well, to the left and down. Okay. Now, the book already gave us the answer, so I'm not really answering the question. This would have been our answer, but I'm just going a little bit further to write all of the information. Okay. Where the book does not give me this answer, well, it did. I kind of cut that off. I knew it would end up over here, so I left that. I tried cropping that image. So in this case, it wants us to move. It wants us to move the triangle back 4 units to the left and then up 1. So grabbing all those coordinates, that's what I did. I took away 4 from the left column, so 2 minus 4 is -2, and so on. And then I added 1 to these coordinates, and I got my image. Now, so I graphed all these -2, 2, -2, 2, that was x prime. Y prime was -1, 4, so I went -1 up 4, and then z was -5, 4, so z prime is -5 up 4, and then I get the image. Now, what's nice about my iPad is I can drag this around. So I can drag, 1, 2, 3, 4, up 1, and that's what I have. You don't get to drag and drop it, but, that's just another view on what it would look like. Okay? This next one, describe the translation rule from PQRS to P prime, Q prime, R prime, S prime. So in this case, we went to the left, so x minus 1, 2, 3, 4 units, and then we went up 1, so y plus 1. And again, the whole trapezoid is doing this. So if I map it out, I have these 4. 1, 2, 3, 4, up 1, and there we are. Okay. So I wrote it as x plus 4 and then y minus 1 with the mapping notation with the arrow mapping notation. All right. So now in this one, it says write the rule to describe it. Well, I only see the pre-image. So what I did was I wrote down the pre-image coordinates. L was at -6, -1. M was at -4, -3, and N was at -1, -1. And then I just took these because they gave me the image, and I wrote that down first. So really, this order should almost be backwards because I wrote down all of those first. I wrote down these, and then I said, what pattern? What gets me from -6 to 1? Well, I have to add 7. What gets me from -4 to 3? I have to add 7. What gets me from -1 to 6? I have to add 7. So I got the rule as x plus 7. And then I said, okay, well, how do we get from -1 to -2? I take 1 away. How do I get from -3 to -4? Take 1 away. And how do I get from -1 to -2? Take 1 away. So the end result here is x comma y maps onto x plus 7, y minus 1. And that's the rule for that. All right. And we went on and we did the rest of this in class, but we spent quite a bit of time on that, so I'm not going to go over it, but you can, follow along with all of the notes, and I answered all of the questions for that, and then also for the practice worksheet. Okay, and you can book an appointment with me if you have any other questions. All right, and that was 9-1, the first lesson of our unit. Good luck.